Hi guys, in the previous video we talked about the reaction time, the reaction distance, the braking time, the braking distance and the stopping distance. In this video we are going to see how we can calculate the reaction time, the reaction distance and the stopping distance from a velocity time graph. So here I have a velocity time graph. And this graph actually shows how the velocity of a car is changing over time during the reaction time and the braking time. So first I'm going to divide this graph into two parts. So the first part is, let me change the color, is the first bit here. This bit here, from 0 to 0.6 seconds, the car is moving with a constant speed, and this is the reaction time. And from this moment, the car is slowing down. That means that the brake has been applied and we have deceleration. So let me write it down here. So we have the reaction time, which is 0.6 seconds. We have the braking time, which is from this bit here to that bit. So it's 2.6 seconds. Now I'm going to calculate the deceleration from 0.6 to 3.2 seconds. So if you remember, deceleration is a change in velocity divided by a change in time. And I can write it down like this. So deceleration is change in velocity is delta v, and change in time is delta t. So time is this bit here, which is 2.6, and velocity, the final velocity is 0, the initial velocity is 15. So change in velocity is minus 15 divided by 2.6. So 15 divided by 2.6 is, let me round it off, 5.8 minus 5.8 meters per second square. And negative sign here represents that we have deceleration. That means that the car is slowing down or the velocity is decreasing. So that sign here tells us if we have acceleration or deceleration. Now what I'm going to do is I want to calculate I'm going to work out the reaction distance, and then the braking distance, and then the stopping distance. Right. Look at that. We had a triangle like this, which is distance, velocity and time. So distance is velocity times time. But we don't use this formula, never ever. We never ever use this formula to calculate distance if the car is accelerating or decelerating, because this formula, we can use this formula if the car is moving with a constant speed. So at this moment I'm not going to use that, and I'm going to use the concept of the surface area below the graph. So when we have a velocity time graph and we want to calculate the distance, we can calculate the area under the graph. So this part here is the related to reaction distance. So I need to calculate the area of the triangle here, which is length times width. So 15 times that bit here is 0.6. So 15 times 0.6 is 9 meters. So this is the reaction distance. Then I have a triangle here, and this part here is the braking distance. So if I calculate the area of the triangle here, I can work out the braking distance. And what is the formula? And the surface area of a triangle is height times base. That base is 2.6 divided by 2. So 15 times 2.6 divided by 2 is 19.5 meters. And if I add these two together, I can get the stopping distance, which is 28.5 meters.